Hello and welcome to Tech Talk with KD. Today's episode is a very interesting episode because it's very techno musical. I mean it, it's technology and music going hand in hand. Because we have Quinton Armitage and Jaswinder Singh joining us, who are the founders of Harmonic Guild, a music-based distribution app which is actually based on blockchain. So the first episode, so this is a 2-episode series. We do the first episode on understanding the technology, which is the hallmark of Tech Talk with KD. So we do what is blockchain in the first episode, and then we go on to the use cases of blockchain, including what they have as their startup. So who better to listen to from a blockchain standpoint than Quinn and Jaswinder. Welcome Quinn, welcome Jaswinder, and Quinn, welcome to India.
Thank you.
Thanks for having us.
So we're going to be talking about the most basic form of blockchain, which is what is blockchain, which is this episode all about. And on Tech Talk with KD, we talk about any technology in its most basic form so that even a layman can understand that, right? So I'll go with the first question, with the most basic question on what is blockchain. Who would like to go first?
I can start with a very simple technical introduction.
Sure.
So in the most basic sort of computer science terms, blockchain is just another type of data structure. Like you have so many other data structures, the way you store your data makes the retrieval and the access easier, difficult, etc. Blockchain is also another data structure, right? The most important property of this new data structure, however, is that it is very tamper-proof, right? Whatever data you store on blockchain, it is very difficult for anybody to tamper with that data. The way they do this is by linking the hash of the data to each block of data, right? So if you change something in that data, the link between two blocks is broken and it is not a chain anymore. So blockchain literally means chain of blocks, and these blocks are sort of connected to each other with the hash of the data inside. So if you want to change something, it is not connected with it anymore. Hence, the most important property of this data structure is that this is tamper-proof, right? And then everything else that we built on top comes from this property of the data being tamper-proof. So blockchain in simple terms is another data structure which gives you this tamper-proof property with the data. And now you can think of so many things you could do.
Still too technical. If we can have a more simpler analogy to it, right? I mean, if we can make it a little non-technical,
yes,
to make the people understand more.
Sure. I would say it's a distributed ledger where anybody can make entries and can access these entries, right? What is a ledger and how these entries work? I think Quinn could give a better analogy for this.
Sure. So you can imagine a blockchain ledger as a photo album that is shared across a family that lives, in different cities on different continents. So let's say, you have a family in India, one in the United States, and one in Italy. Every time they want to put a photo in the album, they take a timestamp of when that photo went into the album, and then each of the other family members in a different city, they also update the photo album to include that picture. And so when Josh talks about tamper-proof, that's, me as a member of this family not being able to remove the photo of me with ice cream all over my face. There is a very strict set of rules enforced in a family, I guess, by the aunties, but, in a blockchain ledger enforced by economics and computational mathematics that enforce this kind of rigorous ledger of the status of something, in this example, photos in an album.
Right. So you're saying people around different continents can share that data, or in this case, photos, and we would not be able to remove the photos from it, right?
Or change them.
Or change them. It makes it very, very tamper-proof, right? Which also puts me on to my next question is we're essentially talking about a huge network out here, right? So let's stick to the family point, right? Let's say there are 10 different points within the family, right? 10 locations, 10 cities, the family is there, my own family and my extended family. Now, all of these guys, they need to have their own infrastructure for uploading the photos, downloading the photos, or is it centrally located, or is the network like for blockchain is like completely distributed? So how do you, what it is like?
Sure. It is completely distributed.
Okay.
And so when you go to, say, add another photo, you add that photo to one node, or one, you just give it to your auntie. And then it is that change, if it agrees with the rules of the network, then that change is updated in every other node.
And who puts these rules in the network?
So the rules in the network are defined in the mathematics and energetics that run that define that network. And so when the blockchain network is built, it has a certain set of rules, and then those rules are copied in every single node operator.
Okay. Can you elaborate on the node operator?
Yeah. So let's say a group of friends started this network, right? And they have written down in code what are the rules of this network, right? When can you add a photo? Who can add a photo? What does a timestamp mean, etc. And then everybody is running this piece of code on their different computers. So there are 5 friends living in 5 different countries who have agreed to join this network. Now, whosoever joins this network will have to run this piece of code. So when you're running this piece of code, you are indirectly just agreeing to the rules which were set up when this network was founded. And you can upgrade the rules with a consensus. If everybody wants to add a new rule, change a new rule, remove an existing rule, they can sort of do it. But as far as rules go, this is piece of code that everybody is running on their computer. So that's how they agree to rules, by running that piece of code.
Does it also bring about, so I was hearing something about a term called smart contract coming in between. Are these rules a part of that smart contract, or?
Yes and no.
Okay.
In the blockchain world, people would use this initial set of rules. They would call it the genesis conditions, or the genesis block, like how it all sort of started. And when they want to do something else or some other use case, they usually call it smart contract. But you're right in that sense that it is a smart contract between the members of the group, right? The members of the network are agreeing to a certain social contract, and that social contract is sort of implemented via written code. And code sort of never lies, code won't back out. If it is the same code, it is going to execute in the same way and produce similar output on different computers. So
and that's
it is a social contract.
And that's an incredible feature, right? The fact that you can put a certain amount of code into a blockchain and it will operate the exact same way every single time. And no one can change that without agreeing to the rules of the chain. That means, there's this classic example of a vending machine. So if you go to a vending machine and you put in money, you will receive candy, right? So say you have a piece of code that does exactly that, where the candy is, I guess, a photo of candy. You put in the money and you will receive the candy, and no one, neither you, nor the person who operates the vending machine, nor any of the other node operators, or anyone involved in the system, can change that code. They can't give you a piece of pizza when you put in the money into the candy vending machine, because it is supported by the computer network itself and can't be changed. And so this has a ton of logical extensions into bunch of different applications that are super useful for allowing people to interact with computer networks in a way where you don't necessarily have to trust the operator of whatever system that you're using.
Right. Yeah, I've heard a lot of use cases, and I'll come to the use case part and the application part later. But before we move over there, I wanted to understand how easy or difficult it is to set up a blockchain network. When I say I understand that there are millions of people in the network, right? Or millions of nodes, as we would want to call it. I can become a node as well. You know, I can have my own mini setup with a node. And you know, there are public. Are there any public clouds where if I want to utilize a blockchain service, I can go subscribe to that and utilize it, or do I have to have like a huge setup for having my own blockchain node or nodes, as you know you may call it? So I just wanted to dive a bit deeper into this, the tech part, the hardware and the infrastructure part of setting up a blockchain.
Right. I think what you're saying is, if there's an existing network, how do you now become a part of this network? How do you run your own node and sort of join this network, right? So first of all, let's talk about how this depends on the network itself. Because for instance, today, there are so many networks out there. There are networks which are working on money, there are networks which are working on smart contracts, etc., etc. So there are so many blockchain networks, blockchain protocols, as you might want to call it, exist, right? And all of these networks, all of these protocols have their own priorities. Some of them want people easy access to running a node. So their node setup is very easy, and the hardware specs that you need are also very easy. Some of these protocols are very computation intensive, so they have less number of nodes, but each node is very computationally super and has a lot of good specifications. So it depends on the chain you want to join. Now let's talk about you want to join an easy chain, a chain which says millions and millions of people can be a part of the network. So to run a node, the costs are very low. The computer that you need doesn't have to be very high spec, doesn't have to be a super powered HPC sort of computer. There are certain ways you could do it. The easiest way is, let's say it's an easy spec computer. It doesn't need a lot of RAM, doesn't need a lot of memory. The easiest way to do it is you can run it locally. And most of the blockchain protocols have their node system code online, open source. So you can go to any open source platform, fork the code and start running it. Some of these chains make it super easy for you to run it, just one command and everything is done. Some of these you have to do much more setup. These are usually written in Rust or Golang or even JavaScript. So they would call it as the client, sort of node client code, etc.
So small question out there, you know, pardon me for my non-knowledgeability on that. But I just wanted to also, can I run it on my laptop? When you say a computer,
yes,
laptop, you know, I talk about it.
Yeah.
Can I run it on my laptop?
Yes.
So
for some chains you can, for some chains you would need a bigger system.
But my laptop goes offline all the time, right? It's only online when I am working on it.
Right. So your node, as any other system, can also go down. When it gets back, when you turn it on again, it can sync everything which happened when it was off. But that's not really a reliable system, right? You wouldn't want a server to go down because the customers won't have anything to call to, right? So if you want to run a node, if you want to run it for yourself, you can run it, turn it off, then turn it on, sync it, and then use it however you want. But if somebody else's use it, they wouldn't want the server to be down, etc. Think of the node as the server. If it is highly available, more people will use it. People will even pay you for this service.
Yeah, so that was my next question as to what's the motivation for me to run a node, right? I mean, to keep running a node, a blockchain node. Do I get incentivized in any form or manner?
You do. So So the average user is not going to run a node, right? They're just going to have some amount of cryptocurrency in a wallet, and they will send a transaction, and then some other node operator will take that transaction. You, as the node operator, will receive cryptocurrency for the service of providing the uptime of the node or for processing the transaction, depending on how the protocol defines these things.
And let's say, I'm just, since you both are co-founders of a startup, I'm also wanting to wear a startup hat. Let's say I want to start a node service. How easy or difficult it is, and is there a public cloud offering which I can subscribe to and run a node service? And obviously I would have to pay to that public cloud offering, but I will also be able to get incentivized and build a business out of it. Is that even possible?
It is possible, absolutely. Whether or not the economics will make sense will depend on the chain, will depend on how efficient your code is, but yeah, it is certainly possible.
You would see a lot of startups trying to API the whole thing. Like instead of everybody being able to run a node, which is, I would say, fairly complex, if not very complex. A lot of people are now starting businesses where they're running nodes for you and giving you a very Web 2-like API-fied interface to do whatever you want. If you want to read some data, if you want to write some data, they will give you simple APIs, and you can have your API keys and you can access the node data, the blockchain data, you can submit transactions, you can read transactions, everything you want to do. So there are plenty of startups already doing that, right? As far as running your own infra goes, you can, let's say, buy simple machines on your cloud and install the whole node code yourself and then run it. But nowadays, even the biggest clouds are giving you out-of-the-box services. They will say, run a Bitcoin node, run an Ethereum node, run an XYZ node, etc., etc.
So all the hyperscalers have it?
Yes.
Like
the major clouds these days are jumping onto the opportunity. Earlier, because some of these Web3 born startups who are giving these API services are also just behind the scenes running these big clouds. Right? They're using these big clouds and running nodes on that, and then giving you an abstracted API service. Then the big clouds are like, why don't we should just go ahead and do it as well? So they are doing it too now. Some of the Web3 players are way ahead of them in terms of accessibility, security, etc., etc. But yeah, both business models are present.
Would you like to name a few public clouds that are there in the space where where we can actually go and start a blockchain node?
We personally have not sort of used any cloud, but I think Microsoft Azure, I think I read Microsoft Azure was going to let you start a Bitcoin node, start an Ethereum node. AWS also has similar services. I think AWS is more prominent. Google Cloud as well.
All of the big.
They're giving you this ability to run nodes for the most popular blockchains out of the box. But yeah, that's it. And there are Web3 players which are way ahead of the game. For instance, there's a Web3 player called Alchemy. They let you go and start any node you want and start using their APIs. They have free tiers, etc. So yeah, all of those are there.
Okay. I'll get into a little bit more technical stuff where, I've heard this concept of getting consensus, right? In a blockchain transaction, right? Normally it's a 51% or more kind of a thing where you need to get the consensus. Can you touch that point a bit?
Sure. So decentralized computer networks have a ton of, there are a lot of different ways that a computer network needs to be resilient against malicious actors, or even malicious actors conspiring, or even people throwing huge amounts of money as well in the form of cryptocurrency at these problems in attempt to make some malicious change to the blockchain. So the classic example is the double spend, right? I send money to you and I send money to you at the same time, and I only have enough to pay one of you, but I send it to one node and then I send it to another node, and at the same time, and then, so that is kind of the traditional thing that these node networks are designed to stop. And so those are usually handled by just the traditional, computational and cryptographic components of operating the network. There are also sort of malicious node attacks, which is when somebody tries to either bribe or spin up a whole bunch of nodes to get to 51% of the network. Those are largely secured by the economics of the system. So in proof of stake systems, which is kind of the third generation crypto systems, you can't control 51% of the network unless you control 51% of the money value, the cryptocurrency-based money value on the network. So it is prohibitively expensive to attack the network, and that's sort of how the that's sort of the economic enforcement that prevents someone from maliciously attacking the network in that way, and that it would cost billions of dollars in some case to effectively run that through. In first and second generation systems, it's through computer power, where you've heard of Bitcoin mining. Well, rather than operating a node, they're operating a mine, which is just solving geometric cryptographic problems over and over again. And in solving those problems, to attack the network, you'd need 51% of the computational power. And so you'd have to build enormous, server farms or GPU farms to do that.
The idea of the whole incentive sort of system is that it is more favorable for you to be doing something right rather than doing something wrong, right? For instance, the electricity that you would use to do a 51% attack on the Bitcoin network, you can use the same electricity and the same money to mine Bitcoins truthfully and make much more money. Similarly, in proof of stake, the same amount of money that you will use to launch a 51% attack, if you used it truthfully and in the right way, you could make much more money. If it's at the end of the day about making more money, the incentive system is designed a way that it favors and it rewards good behavior rather than bad behavior. So that's how the incentive systems are built.
What the sort of attacks on crypto assets that people often hear about for the most part, have nothing to do with the kinds of network scale, issues that we're discussing here. Most of these sort of, I've lost my crypto asset, most of those are human factors attacks, which are more or less similar to just giving your password to a malicious actor. For the most part, these crypto networks are secure from a protocol level. It's human factors where usually they get...
The attacks you mostly hear about are traditional Web 2 attacks, where you click on a link and then there's a program that runs in your computer, steals the private key and steals your assets, etc. They don't really have to do anything with the blockchain network.
So basically what you're saying is from the consensus building, where we require 51% or more consensus, there can be an attack which is there, and those are really the hacking attacks that are there, which are normal for any system. But it becomes really very difficult to cheat
I mean, if
blockchain.
You look at all the major networks, there hasn't been a 51% attack up
till
to
date.
Yeah,
great.
Because it is such a big coordinated effort to
Makes
do
it.
Takes a lot of money, etc.
Makes it a very, very secure system then, right?
Hopefully.
Yeah. So I had this question on the consensus part, right? So I've heard that in order for a transaction to roll over or roll back, there is some kind of consensus required of more than 51%. Can you touch upon that aspect a bit? What is this consensus all about and why is it required? And I heard it's a very integral part of blockchain as well. So how does it work?
Sure. When somebody submits a transaction to a node, so let's say someone buys a movie ticket, exchanging money for the movie ticket. they submit that to the node, and then that is sequentially updated in each and every other node, right? So if my transaction follows the rules, then each node will update in sequence. If somebody wanted to reverse that, or if they wanted to do any kind of manipulation of the blockchain that didn't follow the rules, they would need to overcome 51% of the network through, they would need to change 51% of the nodes in the network.
Okay. I just wanted to interject over
Sure.
there. So we are saying that, for example, I bought a movie ticket. The current apps which are going on, when I buy a movie ticket, it's just an entry in the database, right?
Sure.
If tomorrow somebody goes ahead and removes that entry, my ticket is gone,
Yes.
right? I mean,
Yes.
an admin can do it,
Yes.
right? So over here, you're saying that once you've made an entry that you have gone ahead and bought a movie ticket, and
Yeah.
that entry goes into the network and it's updated, all the nodes.
Yeah.
If tomorrow somebody wants to do a mischief or remove that transaction out, it requires consensus of at least 51% of all the nodes.
Yes.
And what would that 51% number be around? I mean, wouldn't it be like millions of nodes?
So you would need to own 51. So in a proof of stake system, you would need to maliciously trick or bribe 51% of the value held on the network. So in most modern proof of stake system, that's billions of dollars that you would need to spend to change, or at least $1 billion that you would need to spend to change that consensus. In the older systems, they work on computational power, and so you would need to maliciously abduct more than 51% of the computational power on the network, so that these are Bitcoin mines. These are huge computer systems.
Definitely much more expensive than billions of
Yeah.
dollars.
Oh, okay.
So think of, you could park the number around billions of dollars. You would need at least $1 billion to do a 51% attack.
Has that ever happened?
Not in a major network. No.
Yeah.
Not on a major network.
Yes.
Right. On
'Cause
smaller networks.
If there's a smaller network, such attacks are possible, but on bigger, more public network, which are widely used, nothing like this has happened.
And this is really amazing because it means that you can actually own something on the internet for the first time.
Wow, and so we are going to talk about that in the next episode, which is going to be on the NFT part, and we are also going to be talking about your startup, which is Harmonic Guild. But before moving into that, I just wanted to leave the viewers with, we spoke about blockchain and the basics of blockchain. What's a practical use case that we see apart from the NFT part that we're going to talk about? What's a simple use case for some of the users that blockchain serves?
Sure. There are a ton of awesome use cases, right? Someone is going to make a blockchain version of every application that you can find on the internet. But one that really excites me is voting. And I don't mean like voting for elected officials or for government. I mean more so like voting just in a small group, right? So Jaswinder and I are running this startup together. And there's money in that treasury. And a smart contract on this network means that I need both, to send the money needs, in order to send the money, you need both my permission and Jaswinder's permission. And you can do that for anything on a blockchain network, right? So you can do it for writing and escalating code. You can do it for moving digital assets or for moving money. And that's a really powerful sort of democratic and management tool that is really exciting as a use case that we think can change a lot in the sort of economy.
Wow. So voting, trust is something that comes with voting, and trust is something that comes with blockchain as well. So we'll end this episode right over here. Thank you both
Thank you.
for spending time on blockchain. In the next episode, viewers, we are going to be talking about NFTs and Harmonic Guild, which is the startup where Quinn and Jaswinder, of which Quinn and Jaswinder are the founders, right? So meet you on the other side of this episode. Keep watching TikTok with Katie, and do like, subscribe, and share the channel TikTok with Katie. See you soon on the other side again with Quinn and Jaswinder. Bye-bye and take care. Thank you.